It's like a toolbox for your pocket. The Leatherman Charge AL is a pliers-based folding multi-tool that contains 10 components to help you cut, saw, and twist your way out of any jam. And it's roughly the length of a cell phone. Each year, Leatherman ships out over 60,000 of these mighty gadgets from its factory in Portland, Oregon. The process of making a Leatherman begins with crafting its steel components.
Many of the metal parts of a Leatherman are cut out of a ribbon of steel like cookies with a cookie cutter. This is the machine that does the work. It's a punch press.
This press just cut out the pieces that will be formed into the Leatherman's handles. The handles continue along a magnetic conveyor and fall into a bin for transport to another part of the factory. Now, this forming machine must mold the handles into their final shape. The machine uses 30 tons of pressure to fold each flat handle piece into a U shape that fits comfortably in a person's hand and acts as a channel to house the Leatherman's tools.
When you're making a blade for a knife, you want to use a hard steel so that it'll hold an edge for a long time. The problem is it's so hard that it will break the die in the punch press. Instead, they use a laser to cut out this steel.
A 3 by 8 foot sheet of steel feeds into the laser cutting machine. And the laser beam gets to work, literally vaporizing the steel it touches. The 2,000-degree Fahrenheit beam of energy can cut through steel 3/4 of an inch thick. .154 cm steel is so hard, these blades will stay sharp 3 times longer than ordinary knives. The handle gets punched. The blade gets laser cut. But the Leatherman's pliers, or jaws, are too thick and complex for either process. They're a combination of needle nose pliers, regular pliers, and wire cutters. And they arrive in preformed halves from an outside forge. But the plier halves are not quite ready to become part of a Leatherman. They contain slight irregularities.
They don't align right. You can see they're just a little bit off, and it would make for a sloppy tool.
To make the plier halves uniform, they use a process called coining. The pieces fall through a funnel and spiral down through this spinning bowl feeder. The track feeds each plier half into a grabbing arm, which places it into a die inside the automated coining machine. The coining machine then hits the piece with 50 tons of pressure, flattening the piece into its precise shape. Now it will fit together perfectly with any other plier half in the factory. But before they can take their places in the Leatherman, all of the tools head just down the road to Stack Metallurgical Services for the next process, heat treatment.
A tool can be well-designed and super functional, but it's probably not going to last that long without heat treatment. So you can take this and you can really easily bend it before heat treating it. That's because heat treatment takes metal that can be stamped, bent, or cut and hardens it so that it can actually do the stamping, bending, and cutting.
But the tools don't harden through heat alone. A combination of nitrogen and hydrogen gases within the tunnel cools the metal after the intense heating and changes its crystalline structure, making it extremely hard and inflexible.
Let's see what the heat treatment process has done for this metal. You probably weren't expecting that. The metal right now is incredibly brittle. In order to actually make it useful, we've got to go to the next phase, which is tempering.
Tempering holds the pieces at a lower heat for a longer period of time. This removes the brittleness from the parts, but leaves them incredibly strong. Once finished, the tools arrive back at Leatherman headquarters, and several make a stop at mass finishing. Workers empty the pieces into vats filled with vibrating man-made ceramic stones and a polishing compound solution. This process removes any rough edges from the components. It's easy enough to dump the parts in, but getting them back out is a different story.
You might be wondering, how do you separate all the metal parts from the ceramic stones? That's where this contraption comes in. It's a magnetic conveyor belt. You just wheel it over and it sucks all the metal parts out.
While the other parts smooth out in mass finishing, the Leatherman saw heads to the multi-purpose tool cell to receive its teeth. These teeth are designed to slice through even the toughest material, like wood or PVC pipe, cleanly and efficiently. A worker inserts stamped and hardened steel preforms for the saw into the slotted fixture at an angle. An oil-based coolant within the machine keeps the grinding wheel inside from warping or overheating. As the tray moves through the machine, a grinding wheel inside creates ridges in the saws that point backward from the tip. The grinding wheel then carves material from these ridges, creating teeth. Regular push-motion saws can bend and break if their teeth get stuck during use. But with its teeth pointing backward, this saw is designed to be pulled through material instead of pushed, which helps prevent breakage. While the saw gets its teeth, the straight knife also gets some attention. A robotic arm grabs the blade and holds it against the grinding wheel, which grinds the blade and creates its slant. Next, it's off to the knife sharpener. Here, the blade's cutting edge is made razor sharp. Finally, another robot buffs the knives against a felt wheel.
When they get done, let me show you. This blade is amazingly sharp and ready for final assembly.
Meanwhile, the jaw halves come together to form a functional set of pliers. Then a worker tests the pliers to make sure that the alignment is perfect. Each set must be able to cleanly slice a piece of paper with the wire cutters at their base. These wire cutters are so strong that they can repeatedly cut through a construction-grade nail. In the last step before assembly, the finished tools receive their cosmetic finish, and the Leatherman's pliers get very special handling. This robot's job is to polish the pliers, and it's more agile than any human. It moves on 4 axes to hold the pliers against sanding and buffing belts. and recreates exactly the same motion over and over to within 5 millimeters. Finally, it's time to reveal how they fit the Leatherman's 10 tools inside these compact handles. First, a worker affixes a tool locking mechanism to each half of the handle. This lock keeps the tools from closing while they're in use. Workers next stack the tool's components into the channels of the Leatherman's 2 handles. At this point, they also affix a black handle casing to both sides of the steel handle. Finally, the blades and jaws anchor at the other side of the handles. The second half is then attached to the pliers, and the two sides of the Leatherman become one unified tool. Every tool is inspected. And once they pass this test, they head for store shelves around the globe.